Hello students, welcome to IMS GATE Academy. In the last class, I started network analysis and I explained about the network elements. In this session, I am going to take the sources. What are the independent sources? What are the dependent sources? How their VI characteristics and everything I will give here now. But I wish to take the ideal sources means you can have the two sources. One is a dependent, one is an independent source, Independent sources are of two types again. One is ideal source, second one is practical source. And also what now dependent sources of different types, current control current source, current control voltage source, voltage control current source, voltage control voltage source. Such a way different sources are there now. Each and everything we can discuss here now. But I wish to start with ideal voltage source. Ideal voltage source. Just now I said independent sources are of two types. One is a ideal, second is a practical I said. From the ideal, I selected the voltage source. How that circuit diagram can be plotted? It is drawn in this way. This is the source we are having. Source voltage, I wish to take it as a Vs. This source I connected to load. I want to select that as a variable. Variable load I connected here. The current which passes through the ideal voltage source, I want to take it as a I. This I can also be taken as a load current itself. The voltage drop across this load, I want to take it as a V. This is a plus, this is a minus only now. This is the V we got. Here I wish to draw the voltage, load voltage versus load current characteristic of how it comes for the ideal voltage source. When we can say ideal voltage source, when the internal resistance of the source is 0, we are going to call it as an ideal voltage source only now. This voltage source doesn't have any internal resistance. At that case, we are going to say this is an ideal voltage source only now. But in this case, I wish to draw the voltage, load voltage versus load current characteristic I want to draw. But I want to draw these characteristics. How we can draw this? Y-axis I have taken as a V. That V is nothing but the load voltage, we know very well. This x-axis I want to take it as a current, load current here now. In this case, you try to change the load lower value to higher value. When the variation of this load is taken place, what is going to happen? Load current is going to be changed. When we are changing the load voltage, whenever you are changing the load, current also changes. But the voltage will be changing or not in this network? Voltage will not be changing. That voltage is going to remain same only now. V and Vs are going to be same itself now. That's why for an ideal case, we can say V equal to Vs. Source voltage and Vs, V and Vs are same. Even you are changing the load here now. Nikhil Gaurav, hi sir. Yes, in this case, V equal to Vs only now. Whatever the current, even you are increasing the current, voltage is going to remain constant only now. That will not be changed. That's why we can say this voltage is nothing but Vs. So we are saying V and Vs are same. When V and Vs are same, for ideal case I said, for ideal only. Here what property we need to understand from this diagram? This load voltage depends upon this current or not. It does not depend only now. It doesn't depend only now. Even the variation of the current is taken place, we don't find load voltage to get changed only now. That voltage is going to remain same only now. That's why here the property we can write the load voltage does not depend upon on load current only. On load current, we can say that now. Load current. That point is very, very important. That means whatever the change of this current is taken place, that voltage is going to remain same only now. That's why V and Vs are same, but impedance will be changing and current will be changing in this circuit only. This is ideal voltage source. But what about the practical voltage source? I will draw here now. Practical voltage source. Practical voltage source. How the practical voltage source is to be drawn? In the practical voltage source we can draw in this way. Suppose there is a source. That source I have taken as it is, plus minus, this is Vs. The internal resistance of the source is to be considered. When the consideration of internal resistance of the source is made, then we can say it as a practical voltage source. So we can draw a resistance in series to what? This source only now. This source. That internal resistance, I want to take it as a RS, source resistance, I want to know down here now. Then I want to connect a load. That is a variable load I connected here. That load can be changed. And also the voltage across this load, I want to take it as a V. This is the load voltage. V is the load voltage. I is the current, I can say. So what you could understand from this diagram, whenever the practical voltage source is considered, the internal resistance of the source is to be connected in series to the what? Source only now. Source only now. If the load voltage is always less than what now? Vs only, you will get it now. When load voltage is less than the Vs means one resistance is a must. That resistance must be a what now? Which is existing in the source only now. That is to be taken Rs only. But we should not say that Rs is to be connected in parallel cell. It's not accepted only now. If you are connecting the Rs parallel to the Vs means what is going to happen now? Voltage will be same. Vs what now? Voltage across Rs and source will be same only now. But as we are getting the load voltage less than the source, what is required? A series resistance is required. Then only some drop is possible across the Rs. That's why we need to connect the what now? Rs in series, not allowed in parallel only now. That point is very important. That's why practical voltage source is drawn with Rs in series only here now. But here I am asking now, how we can calculate the value of V from the given network? The value of V we can find by this way. Because Vs equal to voltage across Rs plus V only now. I am saying here now Vs equal to I into Rs plus load voltage we can say. I am in need of V. How to get V? V is nothing but Vs minus I into Rs again right now. So based upon this equation only, load voltage versus load current characteristic curve is plotted only here. How we can plot? Please watch it now. I want to plot here now. Load voltage versus load current characteristics I want to draw. Characteristic we can draw. How we can draw this? In the x-axis, I can put current. In the y-axis, I can load current. This must be a load voltage only, V. We know very well, when it is in ideal, it comes in this way. Dotted lines I have taken here now. This is what Vs value I said already. In this case, V equal to Vs is possible, I said already. When? For ideal, I said already given. Whenever it is a practical case, what is going to happen now? When you are changing the load, you think it's so. Variation of the load is made. What is going to happen? Variation of the load is made. The V current also changes only. When the current is changing, V also changes only. For example, this V value we are increasing. This V value I want to increase. What way this I value I want to increase, I say. I value I want to increase. How I can increase the I value? The load resistance is to be decreased only here now. Whenever the decrease of the resistance is taken place, current is going to be increased only now. At the time, difference of this voltage will be decreased. Whenever the current is increasing more and more and more, voltage also decreases. What now? That decrease will come in this way only now. It comes such a way only now. There's a practical voltage source can give the VI characteristic of such a way. Why it is going down, sir? Due to reason, what reason? Due to existence of the RS, what is going to happen now? V value changes only now. The V value change is possible with the change of what? This I value only. The change of I also possible with the change of what now? That load only we can say. So this characteristic curve I can get for practical only now. For practical voltage source only. Voltage source I can write. That's possible now. So these are the two cases are possible. But in this case, what I can say, the change of load current changes V or not. 100% changing only now. Because this load voltage is a function of the current I only now, load current only now. That's why here the property what we have to understand here now, load voltage, we can say the property of this practical voltage source, practical voltage source is a function of what? Practical voltage source, not practical, what? Load voltage only now. Exactly, we can say load voltage only now. Understand now. That is exactly load voltage. If it is written, it is best. We can write clearly like this now. Practical source has practical source. In practical source I can write now. In practical source, what source? Voltage source. But load voltage is a function of load current we can write now. Load current is possible. This is the main property. In ideal case, it is not a function. It is not dependent on only now. It is a independent. Load voltage is independent of what now? Current only. But in practical case, practical voltage source if it is taken now, load voltage is dependent of what? Load current only here possible. These 2 points are very, very important only now. Understand now. These are the voltage sources are possible. Now we can enter into the current sources. Current sources. But there are two current sources we know very well. One is the ideal current source, second one is said to be practical current source only now. One is ideal current source, ideal current source I can write. And second one is to be taken voltage, what now? Practical current source only now. Practical current source. Like that we can put these two types only, we can say. Initially, I wish to explain the ideal current source. Yes, we can note on one side, ideal current source. Ideal current source we can put. But how this network is to be plotted now? This network we can plot in this way. There is a current source. I have drawn this as a IS. The internal resistance of the what now? This current source we are going to neglect only, we can say now. Whenever we neglect it, then only we can call it as an ideal current source only now. In general, if there is an internal resistance now, that must be drawn parallel to the what now current source only now. In ideal case, what is going to happen now? That resistance, that resistance is to be removed only now. That means open circuit only now. The source resistance is to be open circuited only now for ideal current source only now. Here to be connected with a load. Here to be connected with a load only now. That load is a variable. That may be a resistor or inductor or capacitor, anyone we can connect only now. The current passing through this load can be taken as a I. The voltage across this load, I wish to take it as a plus V only now. This is the ideal current source only now. But how the VI characteristics of load current versus load voltage is to be plotted, that is very important here now. I want to draw the diagram in this way. Load current versus load voltage. Load voltage characteristics. How we can draw? The x-axis is to be taken with voltage here now. Whenever it is a voltage source, x-axis is taken as a current, y-axis is taken as a voltage only now. But in the current source, x-axis is to be taken as a current, load current here now. Sorry, voltage, this is to be taken as a voltage only here now. We need to take this as a voltage only now. And y-axis is to be taken as a current only here now. This is the load voltage and this is to be taken as a current, I. But in this case, whatever the variation of the load is made, this load you try to increase, otherwise you decrease. What will be changed? This voltage will be changed. Current will not be changed because of the series circuit only now. In the series circuit, same current is maintained. I and IS is going to remain same. I equal to IS is possible in ideal current source. Whenever you maintain ideal current source, these two will be same only now. But what will be changed? With the change of this load, voltage will be changing only. The variation of this will be possible. Current remains constant only now. In that case, what I can write, I and IS are same. I is going to be IS. I is going to be IS. This I is not dependent upon this voltage only. When I is not dependent upon this voltage, how that characteristic curve is produced? It comes like this only. Constant voltage only possible, constant current only possible. Current is going to remain constant. But the fluctuation of this voltage is possible. Variation of this voltage is possible only. Exact what? Variation of the voltage is possible due to change of this load only now. So the point what I said now, in this case, I equal to IS always for ideal case only now. Now the what property we can write for the current source? In ideal current source, load current is not dependent on what? Load voltage only here now. That point is very important. We can write the property here like this now. load current is not a function of, it is not a function of voltage one. It is not dependent. Not dependent means it is not a function of. Load current is not a function of, load voltage, we can write. This point is very important. Load voltage. Even the variation of the voltage is done, current will not be changing only. This is ideal current source, we can say. Now we can see the practical current source, how to be plotted now. Practical current source, I will note down here. Practical current source. Practical current source. But how that practical current source I can draw? There is a source current IS. This is IS only. This must be connected parallel to the resistance. Parallel to the resistance. That resistance is nothing but the internal resistance of the source only, RS only. And this must be connected parallel to the load. I selected that load is nothing, that load is variable only. I wish to select this load as variable. This is taken variable one. The load current which passes through this, the load current here passes is I have taken here now. The voltage drop across this load, I want to take it as a V. If it is taken as a V, drop across that RS also same only. Drop across RS also same. Why sir? Those two are in parallel. So I can write the drop across this also V only. This will be V. So what current is passing through the RS? If I ask, anybody can say V by RS only. That much amount of the current is passing only now. Sir, why should I connect RS in parallel? Because the load will not receive same IS. Same IS cannot be received by the what now? Load only now. Same IS is not received means what is the meaning now? Some current is diverting. It is to be diverted means one more path is must. How we need to connect? It must be in parallel only. Whenever you connected RS in parallel to the source, then some current will divert, the rest of current will come only now. The load current is decreasing across the load as compared to the IS means we have to think the rest of current will pass through the what now? Some other direction. Some other direction means it must be connected one RS in parallel to the what now? Source only now. That is why it is drawn parallel to the what now? Source only. It should not be connected in parallel, series only. If we connected that resistance in parallel, what is going to happen? The current will be same. I need to receive at any load what same? IS only. But practically in practical current source, the current across the load will be changing only now. The current is less than the IS only I am getting now. Less than IS I am getting means 100% we must connect RS parallel to the what now? This source only now. Then extra current will divert this side only now. Understand now? That way we can draw. But in this case, how I can measure this I value? The I can be drawn, the current I is drawn as a what? IS minus this. IS minus V by RS only. V by RS. We know very well IS equal to V by RS plus I. Otherwise, if you got doubt means you can write like this also. IS equal to V by I plus V by S also, V by RS also we can write. From this what is I? IS minus V by RS only now. But in this case load is a variable or constant I said, the load is a variable only now. When the load is changing, the voltage also, when the load is changing, current also changes, load current also changes. When load current changes, voltage also changes only now. Whenever this voltage is increasing, the difference of the voltage, the difference of the current will be decreased only now. At the time this load current will be decreased only, I can say only now. More and more voltage drop, less and less load current is possible. Now how we can draw the VI characteristics, I and V characteristics of the practical current source. We can see now. There's a load current versus load current versus load voltage. Load voltage characteristics I want to draw. How I can draw that? It can be drawn in this way. The y-axis is to be taken as I, this is the load current. The y-axis is, x-axis is to be taken as a V only. I said already, if it is an ideal current source, it is in constant only. It is constant only possible. The I and IS are same, I said already. If it is IS, I and IS are same. When I gave this diagram, if current source is ideal, in that case, I can draw like this only. Whenever it is a practical current source, what I said now, when voltage is increased, current is decreasing only now. At the time, this diagram will go down only like this. Like that only it goes. This is for what? This is for practical current source. For practical current source. For practical current source, I can draw in this way. For practical current source, I can draw. That way we can draw only now. I think you followed what is the current source and what is the voltage source here. The next one. But ideal sources are completed now. Now we can enter into the what now? Dependent sources here now. Dependent sources. Dependent sources we can say. The dependent sources can also be called as a controlled sources also, or controlled sources we can call. Controlled sources we can write. In that way also we can write it. It is acceptable. What are the dependent sources are there now? There are different types of this dependent source only. A dependent source may be a what now? Current source is possible, voltage source also possible. Dependent voltage source, dependent current source are possible only now. So, but that voltage depends upon the what now? Some of the current passing through some other element, and voltage will be given in terms of the current. That means that current will be passing to some other element only possible here now. I say how I can write here now. It is a dependent source. Dependent source. The dependent source is a current or voltage possible. Is a current or voltage possible. Any one it is possible. But mostly we can find these dependent sources in the analog circuits, because BJT is there now, bipolar junction transistor. It is a current controlled current element only now. It can act as a current controlled current element, because IC equal to beta into IB. The change of base current changes the IC. Current controlled current element they will plot only now, equal in the equivalent circuit only now. And a JFET is there now. There is a voltage, but based upon the what now change of the what now voltage, current also changes the now. Understand now? Anyhow, dependent source is a current or voltage source only possible. Voltage source. Anyone it is possible here now. But there are different, but mostly this dependent source will be drawn as a what now? In the form of what now? It will be drawn. It is written in the form. It is written in the form. How we need to draw? Y equal to Kx. They will write like this now. such a they will write y equal to kx. That form they will write only now. The y may be a voltage or current possible. X may be the current or voltage possible only now. That means the y may be a current or voltage. May be a current or voltage possible. Voltage. Even x also, what is possible? Current or voltage possible. X may be a current or voltage, that also current or voltage possible. Current or voltage possible. Sir, what about that K? K is called as a proportionality factor. K equal to proportionality factor. Proportionality factor they will call. That way it is written now. But what are the dependent sources are possible? I will draw how that symbol is to be taken here now. Suppose I have taken voltage controlled voltage source. Voltage controlled voltage source, we can put diamond shape. They will draw like this. This is one of the voltage source. This voltage source depends upon K into what now? It depends upon the voltage, some other voltage only. Some other voltage. Some other voltage means, suppose in the problems you will say, while doing the what the now dependent with the dependent sources, I will do the what now certain problems only now. There you can understand how that voltage will be there now. That voltage may be a drop across some other what now element only here now. But this symbol what now, this is the diagram will be given for the what now voltage controlled voltage source only. If it is a voltage controlled current source, it is drawn in this way. This dependent source will be drawn like this now. It is a current source, it is given here now. It depends upon some other voltage only now, K into V. This current source depends upon voltage. That voltage may be a drop across some resistance or some voltage across the capacitance as possible here now. But anyhow, this is nothing but voltage controlled current source. Current source, voltage controlled current source only we can put out. The symbols are drawn like this. If it is a current controlled voltage source, how we can draw? Current controlled voltage source means we can draw in this like this now. This is the voltage source. This is the voltage source. Here I can write K into I. Current controlled voltage source I can write now. Current controlled voltage source. With the change of this current, this voltage will be changing only now. That's why current controlled current source only now. In case current controlled current source means how we can draw? There is a current source here connected. This current source depends upon the current only now. That means K into I. This I may be passing to the any other branch only now. Understand now? Like that we can put now. The Gopi, hello sir, hello. Yes, anyhow, it is a current controlled current source can be drawn in this way only now. This is drawn as a current controlled current source. Current source. Like that, dependent sources is to be drawn only, you can say. Understand now. Next one. Now, I want to explain the Kirchhoff's laws. Kirchhoff's laws. But based upon these laws only, we are going to do the problems of more. KCL and KVL comes under this only we can say. Suppose I selected initially Kirchhoff's current law. I selected KCL. Suppose here I selected certain number of conductors. I connected certain number of the conductors in this way. In this way, they are all arranged only, we can say. Through certain conductors, we allowed current to pass. Through this, I allowed a current of I1. This side current is allowed, I2. This side also current is allowed, I3, I allowed. These three currents are coming towards this junction only. After reaching to this junction, we cannot find any storage or depletion of the current only. Any storing or depletion of current at the junction. The current whichever the path onwards it came will try to go through other paths only now. This can be taken as a I4 and I5 only now. I4 and I5 to be dividing only now. I1, I2, I3 are nothing but the incoming current, and I4 and I5 I have taken as a outgoing current only. What is KCL says? It says the algebraic sum of currents meeting at the point of this junction equal to 0 only. Not only this junction, any junction in the network, if it is taken, it becomes a 0 only now. Algebraic sum of currents meeting at the junction in the network equal to 0 only now. But in this case, we can write this theorem like now. The algebraic sum of currents meeting at the point of junction is equal to 0 only. Junction is equal to 0. Equal to 0 we can write. This is the Kirchhoff's current law we can say now. But here the point what you have to understand here now, incoming current equal to, I can write now sigma I equal to 0 also we can write in this case. Summation of all the currents is 0. Or we can say sum of the entering current equal to sum of the entering current equal to sum of the leaving currents only. We can write the final point, sum of the entering current. Entering means entering towards the node only. Entering towards the node. There is a sum of the entering current. Entering currents equal to sum of the leaving currents we can write now. Sum of the leaving current. Leaving current I can write now. Leaving currents I can write now. Sum of the leaving currents. What are the currents are entering towards the node here now? I1, I2, I3. I can write I1 plus I2 plus I3 equal to, I can write as a what? I3 plus I4 plus I5 only. I4 plus I5 I can write. So, entering current equal to leaving current only possibles. Understand now? Still this can be written in this way also. We know very well current equal to rate of change of charge, dq by dt only. Rate of change of charge equal to current only now. Already we got the equation I1 plus I2 plus I3 equal to we got I4 plus I5 we got. I1 can be written as what now? dq1 by dt only. dq1 by dt. I2 can be written as what? dq2 by dt we can write. I3 can be written as what now? dq3 by dt we can write here. I4 can be written as what? dq4 by dt I can write. I5 can be taken as what? dq5 by dt I can write here now. But I wish to apply integration on both sides. Whenever the integration is applied, what is going to happen you ask now? I applied integration on both sides. The integration differentiation cancel. Integration d by dt cancel. Finally, what is still left? q1 plus q2 plus q3 equal to q4 plus q5 only possibles. So, entering charges equal to what? Leaving charges only possible. Where? In KCL only we can say. Thus we can define finally the point like this only now. sum of the entering charges equal to, these are all entering charges, sum of the entering charges equal to, sum of the entering charges equal to entering charges equal to what we can write, sum of the leaving charges only possible in KCL. Sum of the leaving charges is possible. Leaving charges. This point is very, very important. Leaving charges and entering charges are same only possible. But what property you need to understand in KCL? But the network what is drawn while applying the KCL must have with lumped circuit elements only. Lumped elements whenever you are having, then only applicable this KCL only. Understand now? That's why you can write the point in this case like this only. The KCL is applied property we can write here now. I can write what property we can write for this KCL? Property I want to write. KCL is applied. KCL is applied to any lumped electric circuit. Any lumped electric circuits only. That is very important. Electric circuits. That point is very important now. Understand that now. But and also one more point, whatever it is taken now, it does not matter whatever the elements are there now, whether it is a linear or non-linear or passive or active, or it is not the matter. It is applicable KCL only now. That's why the point also we can write now. KCL is applied to any lumped electric circuits. It does not matter. This point is very important. It does not matter. It does not matter. It does not matter whether the elements are, this point is very, very important, whether the elements are linear, non-linear, and also what now, active or passive, that is not the matter. Active and passive. And also we can write now, is it a time varying or a time invariant? Time variant or time invariant. Time invariant. That point is very important. That means whenever the circuit is with a lumped elements, then only we can apply the what now, KCL we are saying here now. And it doesn't matter now whether it is the element is a linear or non-linear, whether it is a active or passive, whether it is a time variant or time invariant only now. But it is required the circuit with lumped elements. Then we can apply the KCL only, we can say. Where we are going to use this KCL? Mostly to do the what now, problems in the to do the problems in the nodal analysis, we are going to use the KCL only. The nodal analysis, what you will do, whenever you are applying the nodal analysis, I will give the rules in the nodal analysis also. Nodal analysis, whenever you are applying the nodal analysis, it is required. Nodal analysis means what now? You will apply the KCL. After applying the KCL, what you will do, their Ohm's law is applicable only. Ohm's law is applied only now. Whenever this is applied, then nodal analysis will be completing only now. While doing the problems, this will be useful only now. I will do the maximum number of questions also. Then you will get the idea. Before doing the problems, it is required some information now. That basic information I am giving here now. Understand that now. So next ones, KVL. When we can apply KVL? KVL, Kirchhoff's voltage law. How to apply this KVL? What is that KVL? We can see only now. Suppose I have drawn any network, any closed network I have drawn like this. One series circuit I have drawn. This is connected with a voltage source V. This is connected with a voltage source V only. Any number of resistors or inductors or capacitors you can connect in the network only, then applicable here now. The resistance I have taken R1. The resistance I have taken R2 only. The drop across this R1, I wish to take it as a V1. The drop across this R2, I have taken V2 only. In the series circuit, we know current is same. That current I can take it as a I. What it says, KVL? In any closed circuit, this is one of the closed circuit. In any closed circuit, the sum of the voltage drops across the what now? The resistors is equal to what now? Supply voltage only now. Whatever the elements are given here, I have taken resistors based upon that one. I am applying the KVL. In any closed network, sum of the voltage drop across the what now? Electric elements is equal to the supply voltage only. The electric elements, I connected the resistors only. So I will say the voltage drop across what now? R1 and R2 is equal to supply voltage only. That's why I want to write in any closed circuit. In any closed circuit. In any closed circuit. What you can write now? In any closed circuit, the sum of the voltage drops. Sum of the voltage drops across what here? Across these electrical elements only. Here I am putting here the electrical element may be resistor or inductor or capacitor possible. Here resistors I have taken. That's why I want to define the sum of the voltage drops across resistors is equal to supply voltage. We can write it is equal to supply voltage only. This is KVL, Kirchhoff's voltage law, we can say now. But how we can note down the equation here now? That equation I can put like this only now. Supply voltage V equal to how we can write? Sum of the drops V1 plus V2 only I can write. V1 plus V2 I can write now. But still we can write now what is V1? Current into resistance also I can write. What is V2? Current into resistance also accepted only now. Current into resistance also. Anyhow, the formula is more important. Understand now. This is the KVL we can write now. But we know very well the voltage equal to, I gave the definition. In the definition, I gave the what now? Voltage is nothing but work done by charge. I gave it already. dW by dQ is given already. dW by dQ equal to voltage only now. That formula I can apply here only now. When I applied that formula here, V equal to what I can write? V equal to V1 plus V2. I will write here now. V equal to V1 plus V2 we got. V equal to, I want to take it as a dV by dQ, sorry, dW by dQ I can write now. Already given. Already here called dW by dQ. The same time dW by dQ. V1 equal to what I can write? dW1 by dQ I can write. And what about the V2 means dW2 by dQ I can write. Sir, shall I put it Q1, Q2, Q3? The Q why you are not changing, sir? Why can't you take Q1, Q2? Because it is a series circuit only now. Any closed circuit, one series circuit I have taken. In the series circuit, charge will be same only now. The charge will not be changing. That's why I can put that as a what now? dQ only now. Not allowed Q1, Q2, Q3. It is not going to be changed only now. Understand? Whenever I applied integration on both sides, The W equal to what I can find? W1 plus W. W is nothing but the work done. This formula possible. So the KVL is taken here now. But what are the properties we need to know in the what now? KVL. I will give the properties because while doing the problems, these are the properties will be useful only now. That's why I'm giving here now properties. Properties. But the first property, the KVL expresses conservation of energy only here now. Conservation of energy possible. Expresses conservation of energy. Conservation of energy. Then we explain. Energy. In every loop of lumped electric circuit only. The circuit must be a lumped only now. It is not allowed any other circuit only now. Distributed, but no distributed elements are not accepted here now. It must be a lumped only now. That is why in every loop of electric circuit is very important. Electric circuit is a must. Understand now? That point is very important here now. Understand? And here whenever you, where you are going to use this voltage law? Whenever you are applying the mesh analysis, then you are going to use this only now. I say mesh analysis wherever you applied. Mesh means it is required the loop only now. Whenever the nodal analysis you are applying, they require the nodal nodes only required now. By selecting the nodes, current directions are taken, then after apply the Ohm's law only now. Whenever the what now mesh analysis is taken, in this case, we will apply the what now? KVL plus Ohm's law, it is applied only now. Mesh analysis, we can apply like this now. Mesh analysis. Mesh analysis means KVL plus Ohm's law we are going to apply. KVL plus Ohm's law we are going to apply. Ohm's law. That is very important. In that way, this will be useful only, we can say. Understand now. But sometimes the sources I explain, current sources and voltage sources I connected only now. Sudden connections I will give, you can understand clearly only now. Still some more information required by using the sources only now. Suppose in a circuits, you are given the what now? Voltage sources in this way. The voltage source plus minus V1 is given. And one more voltage source is given such a way only now. Two voltage sources are connected such a way only now. What is the total voltage we are going to equivalent circuit we can draw here now? This equivalent circuit we can draw in this case. Plus minus you will take. These two voltages you can add directly. V1 plus V2 you can add now. And single source you can connect only now. That is acceptable. In case you are given like this only now. In case you are given one battery here like this. This voltage with V1. And second source is connected here with a polarity this side. This is given V2 only. Suppose we are assuming V1 is greater than V2 only here now. Assuming it now plus or minus you got all. This is a V1 higher value, V2, otherwise any value no problem. Anyhow, this is a plus V1, this is a minus V2 is given here now. But how that equivalent circuit I can draw? I can draw like this also. Single source you can connect here now, plus minus. V1 higher, V2 lower only now. Here V1 minus V2 it is accepted. V1 minus V2 we can put directly. Single source we can connect only now. That way it is possible now. Understand now. But it is not acceptable. Suppose I connected one resistance like this. One 2 ohm resistance I connected, for example. You will understand clearly. I connected across this one one 10 volts here connected in the network. This voltage I connected 10 voltage only now. This side I connected with 5 volts for example. I connected 5 volts only now. Volts is connected now. Suppose you are asked, can you find the current passing through the 2 ohms? Suppose you are asked to find out the current across this 2 ohm only. Can you find the condition? One of the condition you can understand. That is why I gave this circuit like this only. I connected one 10 voltage this side, 5 voltage this side, 2 ohm this side. Current across 2 ohms you find now. This is an unbalanced circuit only now. It is not a balanced circuit only, you can say. How can you say it is a not balanced circuit, sir? The 2 ohm resistance is parallel to the what now? This 10 volts. This 2 ohm is parallel to the 5 volts also. In the parallel network, voltage must be same only required. This voltage equal to this voltage possible, voltage across 2 ohm. This voltage drop equal to that voltage is possible. But two different voltages not accepted parallel to the resistance only. Whenever you connect it such a way, we can say does not exist only now. Here what I can say, the circuit does not exist only here now. Circuit does not exist, we can write directly. Why it doesn't exist? One side 10 volts, one is a 5 volts, different voltages not possible across the 2 ohms only. Suppose still you got means in an alternative way we can explain also. I connected this side same 10 voltage here for example. Why not accepted, sir? Theoretically you are saying just you do mathematically and give answers, sir. Yes, we can give. This I gave 10 voltage for example. I connected this, I interchanged these two, it doesn't affect only now. I connected here 5 volts. I connected 5 volts also. Here I connected with 2 ohm resistance only. I connected with 2 ohm resistance only. We are in need of current across 2 ohms only now. Suppose I applied the KVL in this direction. I applied KVL in this direction. Whenever I applied KVL, KVL means what now? The sum, but in any closed circuit, what happen now? Some of the voltage drops are taken, means this becomes a 0 only now. Incoming current equal to incoming, that means what? The supply voltage equal to sum of the voltage drops now. The supply voltage minus sum of the voltage drops equal to 0 you must get now. 0 you are getting means it is acceptable only. Here condition satisfying or not, you check it now. When I go this side, minus 10, I will get. When I go this side plus 5, I can get here now. That equal to what? 0 in this particular loop only now. So finally what I am getting here now? Minus 5 equal to 0 I am getting. Can you say minus 5 equal to 0? Impossible. Minus 5 will not be 0 only now. That means KVL is violated in this circuit only now. Then only we can say it is an unbalanced circuit only we can say. That's why here what you can say, KVL is violated here now. Violated. Why it is violated, sir? Minus 5 equal to 0, how it is possible? Impossible only now. That's why if you connected circuit such a way, it becomes unbalanced now. Why it is unbalanced? Some voltage equal to 0 we are getting now. Impossible only we can say. That is why KVL is violated. It does not exist only you can say. Understand now. These are the certain examples of the sources only. Even current also, current source also. Suppose I connected here one of the current source in this way. Suppose equivalent circuits I want to give now. This is the current is passing this side. This is I1 I have taken for example. This side I connected with I2 for example. How we can draw the equivalent circuits? This side current of I1 comes, this side I2 comes, total finally it becomes a I1 plus I2 only. It is acceptable. I can draw in this way. I1 plus I2 is acceptable. Like that we can draw one. And in case you have drawn one more circuit in this way, one network you have drawn like this now. Two current directions are given this side. This is given I1 this side. This is given a current of I2 one. What is the net current? How we can draw the equivalent diagram here now? Is it possible to draw or not? Can I draw with a single current source or not? Anybody can give answer? Can I draw a single current source from the given network? In case if I1 and I2 are equal, that network is acceptable only. I1 and I2 are equal, you think it, so same currents can flow in this direction only now. If the different currents are given, we cannot, it doesn't exist only now. I1 and if I1 and I2 are equal, we can write one sentence now. If I1 equal to I2, it is given, you think it so, then allow a current source. In this case, I1 equal to I2 only. Then I can draw as a single current source also. In case currents 2 are not equal, sir, if I1 is not equal to I2, you got now. In the circuit, I1 and I2 are not equal, two different currents will not pass in the same branch only, we can say. That is impossible now. That's why in that case, if I1 is not equal to I2, the circuit doesn't exist only. The circuit does not exist, I can write now. Does not exist, I can write now. It does not exist only. Directly you can draw only now. This time point now. These are just certain examples only we can say. And one small question I will give, you can understand clearly only now. Suppose you are given here now, I am asking find V, the V value I want from the given network. From the given network. I am asking to find the V from the given network. The network is given in this way. The network is given like this. There is a voltage source. This is given with a 10 volts, for example. Here connected with one current source. That current source is given with a 2 milliamperes only. I connected this with one resistance. That is given as a 2 kilo ohms. I am asking the question here now. The voltage across these two terminals is equal to how much? I am asking here now. Any student can give answer for this question? Any student can give answer for this question? This is my question. Just I will wait for some time. Any student can give answer or not. What voltage you can get from the given circuit? Anybody? What is the voltage V from the given circuit? Given a battery voltage 10 voltage. Current source is connected with 2 milliamperes. Resistance is connected with 2K. Is asking to find the open circuit voltage V only now. Anybody can answer this question? What answer is mostly possible? The student should understand one point. In this network, is it a open circuit or not? Yes, it is a open circuit only. This is open. This open circuit voltage V I want. The many students, what they will do, yes, supply is connected 10 voltage, current is passing this side, some drop is possible, and apply the KVL, and they will get the some answer only. That way it is not allowed only. But you need to understand one point. Whenever the network is a open, network is with open, can you get the current source in the network? Is it going to exist, current source in the open circuit? In the open circuit, current will not exist only. Current is not existing, but in the problem what is given? The open circuit with a current source of 2 milliamperes is given. Is it going to exist or it is not going to exist? It doesn't exist only. Why it doesn't exist now? Open circuit with a current source is not possible practically. That's why the circuit doesn't exist. Directly answer is the circuit does not exist. We can write directly exist. But you should not say, sir, it is an open circuit, sir. At the time, what happened? The current source also, I will open, sir. No, that's why not allowed now. But he gave it in the problem. The network is connected with a current source. The network is it allowed to connect the what now current source with open circuit or not? That point you have to remember. It doesn't. It is not acceptable only now. That is why the circuit does not exist. That means open circuit with a current source will not be existed. That is why we can say the circuit does not exist only, that point only. Next one. That way we can write it into. Next one. Now, equivalent circuits are more important. Equivalent circuits are required. Next one. But after completing all these one, after completing all the basics, I can start the problems. Certain hours I am going to spend for the what now? Problems. I will do number of problems also. Equivalent circuits. Equivalent circuits. But when the impedances are connected in series, some students know very well. Some students do not have the what basics of these also. For them, it will be helpful. That's why this basic. The main purpose of this foundation course is the students who wants to appear for the gate must know well about the foundation. Some students may not be having the but now basics only now. At the time whenever they are attending the classes every day. Otherwise, if they are unable to attend these classes, they can watch later on. But by watching these videos, they can understand the foundation course, whatever it is given only now. Understand now. This will be useful to a lot to every one of the student, I can say now. The first one, equivalent circuit means impedances in series. Impedances in series. If it is connected, what you have to do in the problem? Certain days you are going to find all the rules only. Then after we can start the problems also. Understand, each and every students can understand how to apply each and every one of the formula only now. Suppose you are connected to impedances. One is nothing but a Z1 here. One more impedance is given Z2. Like that impedances are connected one. These are the impedances are connected to the source. Connected to the source. This is nothing but the V only now. It is nothing but a series circuit only now. That current is I. That Z1 and Z2 may be resistors, otherwise inductors, or it may be the what no? Capacitor only possible. Whenever you are given the resistor, you think it's so. ZR I have taken now. That can be taken as R ohms. Resistances are given means R1, R2 ohms it comes. If you are given what no inductor, ZL can be taken as a inductor whenever it is given, ZL can be taken J omega L ohms it is possible. Impedance of the inductor we can take ZL. The impedance of the capacitor if it is taken ZC will be taken 1 by J omega C you are going to use. All these are in ohms only. But how we can take the total impedance? The total impedance Z equivalent can be calculated by Z1 plus Z2 only. Z1 plus Z2. The formula we are going to use. But I will give the resistor network if it is given, how to find the Z equivalent. If you are given with inductors, Z1 and Z2 are given with inductors, how to take the Z equivalent. If the capacitors are given, how to find the Z equivalent, we can see only now. Suppose here given, suppose you are given the resistances only here now. In case you are given resistance here now. Resistance is given. Z1 and Z2 are resistances only. Z1 equal to R1 is given, Z2 equal to R2 is given. Total R equivalent how I can get? Z equal to Z1 plus Z2 I gave to. R equivalent to R1 plus R2 you can write now. Z1 equal to R1, Z2 equal to R2. If it is given, equivalent value of R can be taken by the formula R equal to R1 plus R2. In case you are given the inductors, Z1 equal to what now? In the place of Z1, it is given L1 and L2 only now. Their impedances you know. L equivalent value you can calculate. L1 plus L2 we can write. That formula. Same formula, Z equal to Z equivalent plus Z equivalent equal to Z1 plus Z2 only now. It's already given. Z equivalent to Z1 plus Z2 I gave it now. But a Z equivalent, whenever you want to get, means Z1 equal to what I said. If it is an inductor, what I gave it? J omega L1 I gave. Z2 means J omega L2I. If I cancel this J omega and J omega, Z equal to J omega L. So L equivalent I can get L1 plus L2. Same formula we get now by using that formula only. Understand now? Yes. Anyhow, if you are given resistor network, means this formula equivalent value of resistance. For inductor means L equivalent to L1 plus L2. If it is given capacitor, if you are given capacitor, how to get equivalent value? That is more important. If it is given capacitor, its equivalent value we can take like this now. Capacitor means you see the now Z equivalent I want, for example, Z1 plus Z2 I said here now. Z equivalent equal to, I gave it 1 by C omega I said now, J C omega. C equivalent we can get now into omega. And if it is a Z1 means 1 by J C1 omega possible. Z2 means 1 by Z J C2 omega mostly possible. J to C omega. And finally, what is the value it is available? The J omega cancel now. I can get 1 by C equivalent equal to 1 by C1 plus 1 by C2. This formula is applicable to find out the C equivalent value. This is required. This is required only, we can say. Understand my point now? These are the equivalent values only now. Understand now? And suppose you are given the current division formula, means what we can apply? It is a current division formula, you need to know. Current division formula. Current division formula. In the problems, it is required each and every one of the formula. Without knowing these formulas, we can't do any problems only, we can say now. Stand up. In the current division formula, what happens now? Suppose I am giving resistor network is given here now. Suppose it is given here resistor network. Suppose the resistance, I am giving the direct formula here now. Resistance whenever given, I1 if you want to find. In parallel branches, whenever it is given, you are going to apply only here now. Understand my point now? So just wait. Sorry, before that I have forgotten to give the parallel circuits also. I will give the parallel circuits also. We can do the parallel circuits also. In series circuit, if it is taken here now, backside I gave it, please watch what is given here now. Whenever the series circuits are given here now, the R equivalent we can calculate it by this formula. R equal to R1 plus R2, I gave it. Just 1 minute, I will give the now. Yes, these three equivalent values I have taken now. And whenever it is a series circuit, one more condition I have forgotten to give. I said here now, impedances you are connected here in series, already given. One more impedance I connected Z2, I said already, same. I connected with a source plus minus V. If it is a series network, we know very well it is going to flow the same current only now. That current is nothing but the I said. Whenever in the series circuit current is passing, some drop is possible. That is a V1 only we are going to call. When it is passing through the Z2, we are going to find the V2 value also. And we are in need of these voltages only. By using what formula you can find the what now? Voltages V1 and V2. Supply voltage, these two impedances are given. How we can find the voltage now? There we are going to use voltage division formula. After completing this voltage division formula, we can enter into the parallel circuits only. How to find out the equivalent values of C, R, L, and also current division formula also required one now. Here I wish to find voltage division formula. Voltage division formula I want to apply. How to write this formula? Suppose you want to find, suppose the resistor network is given. The network given is the resistor network. The Z1 is nothing but R1, Z2 is given as a R2 only. R1, this is R2, it is given. Supply voltage V is given. I wish to find voltage across this V1 only now. The voltage across Z1 is a V1 I want. V1 can be calculated by R1 into V by R1 plus R2. By using this formula, you are going to determine voltage across the Z1 only now. By using the voltage division formula. That means to find out the V1, supply voltage into same resistor divided by equivalent resistance, it is taken here now. But in case you want to find out the V2 value, you think it's so. Same way, V2 means V into that resistance is to be taken R2 here, and R1 plus R2 is to be taken. R equivalent is more important. By using this formula, V2 can be calculated only now. That way, V1 and V2 we can calculate if it is given resistor network. In case you are given the what now, inductor here now. Two inductors are connected. In the place of Z1, I connected L1 only. In the place of Z2, I connected L2 only now. How we can find voltage across L1 and voltage across L2 only now? The voltage across L1 is to be taken as a V1 only now. There you can use same supply voltage into L1 by L equivalent value. L equivalent value everybody knows, L1 plus L2 we can apply. In the same way, if you want to find out the V2 value, you think it's so, you can apply supply voltage into L2 by L equivalent value. L equivalent is nothing but L1 plus L2. So these are the formulas we are going to apply for inductor only now. This is for first inductor, this is for voltage across the second inductor only. In case Z1 equal to C1, Z2 equal to C2 is given, in that case, how to find the V1 value, V2 value only now. The formula applicable here is, if it is a capacitor network, if it is given here now. In that case, you can use V1 equal to V into second capacitor you must take by C1 plus C2. It is a must. V into C2 by C1 plus C2. In the same way, if you want to find V2 value, you think it's so. If you want to find V2 value, V into supply voltage into C1 by C1 plus C2 is applicable only now. So this is voltage division formula 1. Voltage division formula 1. Understand now. In the next class, we are going to find the what now, current division formula. After completing the current division formula, I can start the number of problems only. So many problems we can do in the next class only now. Understand now. But if any one of the student is willing to take the coaching for the GATE in IMS GATE Academy, this is the address only here now. And also to have the contact, if you want to contact with the what pupils means, numbers also given here now. Please go through it now. Just have you have a glance, understand now. Otherwise, you can take a screenshot and you can inquiry. You can make an inquiry with the pupil only now. The pupils who are getting the good rank in the IMS GATE Academy, who cracked and got the rank below 20 only, all these people only. All India 3rd, All India 4th, All India 4th, All India 4th, All India 7, All India rank 7, getting students now. These are all the good rankers of our institutions. Like there's so many students still getting only now. Understand the people who are getting below 20 given here now. GATE. But in IMS GATE Academy, it's given the live classes and online classes also. The features are given here now. Go through it now. And also given here, the mobile numbers also given. You can have the contact. Contact numbers are given only now. Okay, thank you very much. In the next class, we can see the rest of what now subject.